Variables are a place to store data. They have a name, which should be descriptive to help you read your code. They have a type, which we'll get into. That might be an integer, it might be a string, it might be a character, and they have a value. So if it's a character, it might be a C. If it's an integer, it might be 411. So if I'm going to use variables, I first need to declare them. So I'm going to declare two variables here, and I am also going to assign a value to x. So to declare x, I provide the type, which is int. I provide the name, and in this case I'm also initializing it, so I provide the value. I can also just declare a variable and initialize it later. So I can declare a variable y, that's also an integer, and then I can assign it a value like 5. And so now I want to actually see what I'm doing here, so I'm going to print over the serial port both of these variables, x, y, as well as the sum. So to do that, I'm just going to put a bunch of code in here and explain it. So I begin my serial port, right? I set the rate to 9600 baud. Now I'm going to print x equals, and then I'm just going to print x, right? So it's printing whatever is currently stored in the variable x, which in this case should be 32,760, right? Then I'm going to print the value y equals, right? I'm going to print that string, and I'm going to follow that up with y, which should be 5 here. And then I'm going to print the sum, which should be 32,765. So I can upload that. It's done uploading, so we can go to the serial monitor. And x equals 32,760, y equals 5, x plus y equals 32,765 as expected. So that's great, but I want to print this over and over again ad nauseum like we often do in our loops. So I'm just going to cut this code out. Oops, I'll leave the serial.begin in there. Cut this code out, put it in loop, right? And then I'm going to try to upload, and I got a problem, right? And this is a compiler error. So what it tells me is that x is not declared in this scope, which basically means inside the function loop, it knows nothing about the variable x. And that's because the variable x was declared inside the function setup. Same with y, so I'd get the same compiler error if I fixed y. Now the best way to fix this is to instead make x and y global variables. And this is often frowned upon in software classes, and if you write a lot of code or very complex programs, global variables are in general a bad idea. But in the short kind of things that we're going to do in this class, global variables are no problem. So I'm going to take that x and y and move that outside of my setup function. So now x is declared and initialized outside setup and loop. It's a global variable, so I can actually access it inside setup or inside loop. And in fact, I can keep that declaration or that initialization in setup, and it should still be able to access y, and the print line statement in loop should also be able to access y. So I'm going to upload this. Great, it's done uploading, so we can look at this on serial monitor. And it should continue printing this, and it's doing it fairly fast. All right, I can add a delay there to make it slow down, but it's printing it correctly. But let's try something crazy. Let's make y equal to 8. And I'm going to add a delay function in here as well so that I can see what I'm outputting. I'll make it a full second. I'm going to upload this, and let's see what happens on our serial monitor. So what this is telling me, if you can read it, is that 32,760 plus 8 equals negative 32,768. I don't know what kind of math you learned, but this is not the kind of math I learned. And this is indicative of the type of variable that I made x and y. I made x and y ints. And if I go to my reference page, and I go down to this data types thing, and I click on int, what it tells me is that int is a signed 2-byte number, which means it goes from negative 32,768 all the way up to 32,767. So when I added 32,760 plus 8, I was outside of the range, permissible range for an int. So I can fix that in a number of ways. If I go back to my data types that I have a variable, I have an unsigned int, right? And that allows me to go from 0 to 2 to the 16 minus 1, or 65,535. I also have longs and unsigned longs, and longs are 4 bytes long, so they go up to 2 billion plus, negative 2 billion plus to positive 2 billion plus. So what I'm going to do here is change both of these to longs, and that should solve my problem. Now this takes an extra 2 bytes more than I need to, but it allows me the possibility of keeping these things, making these things negative, or result in negative numbers if I need to. So I'm going to upload this, and I'm going to open the serial monitor. So now it adds everything correctly again, right? Because we have the correct variable type associated with our variable. Right, types come into play in mathematical operations as well. Right? I've changed x and y back to integers. I've made them initialized them to 3 and 7 respectively. I've also declared a variable z. Right? So I print x and y the same way I did previously, but now I'm assigning z to the product of x and y. So I can upload this and look at that on my serial monitor, and I indeed get 21 as I expect. But what if I divide instead by y? I'm going to upload this and check it on my serial monitor. I get 0, right? Clearly 3 divided by 7 is not 0, but I've declared z to be an integer. And integers can only be whole numbers. They can't be fractions or decimals. So what I can do is change z to a float. And when I do this, I want to point out one other thing to you. So right now the sketch uses 2530 bytes of code. When I change z to a float, which is a fairly simple change in my code, and upload that, now I'm at 4150 bytes of code. Right? So let's see if that fixed our problem. Go to serial monitor. Let's come up with a creative way to keep it broken, right? So now z is 0.00, so it's still 0, whereas it should be whatever 3 divided by 7 is. So if I go back here, what I've run into is the problem that when I assign z, I've already done this division by integers. So what I'm going to need to do is cast one of these as a float. So what putting this float in parentheses in front of x does is makes x a float temporarily for this operation. So if I now upload this and look at this on serial monitor, I get the correct division of 3 divided by 7 as 0.43. And that's because I temporarily cast x, which is declared as an integer, as a float for the purposes of computing a float, which is z.